Hello everyone, welcome back to our video on algebraic expressions. Now we're going to be working on the long, hard word problems which usually show up on exams in the part C section. Okay, so these are very typical exam type questions and they show up on tests as well. So this specific question here, they're asking us to find the area of the shaded region. So we're given two rectangles, a large rectangle, and within the large rectangle we have a smaller rectangle, and we have to find the shaded region, the area of the shaded region, what's in blue. This is very typical, so the game plan here, to find the area of the shaded region, what you have to do is take the area, you have to find the area of the whole shape, area of total shape, and you have to essentially remove the middle piece. So you're taking the area of the big rectangle, minusing it by the area of the small rectangle. And what you're left with is the area of the blue, the shaded region. So A total minus area of the small. So total being the entire shape. So this is the game plan. So we have to find the area of the total, the big rectangle, and minus it by the area of the small rectangle. Okay, that's not too bad. So let's start off with finding the area of the big rectangle. So let me call it big rectangle. We'll call it big instead of total. Area of the big is length times width, because it's a rectangle, and the length is 3x plus 12, and the width is x plus 5. So here we have to FOIL. So 3x times x is 3x squared, 3x times 5 is 15x, 12 times x is 12x, and 12 times 5 is 60. No. Yeah, 60. Next we combine like terms, and we get 3x squared plus 27x plus 60. Whatever the units are, so units squared. This is the area of the total shape. Now our goal is to find the area of the small rectangle. This is a bit more difficult because we don't actually have the dimensions here. So there's a bit of work that we have to do. And this is a trick that we saw in a previous problem. So let's start off with finding the height of the small rectangle. How do we do that? Well, notice that it's a vertical distance. You're looking for a vertical distance. We know the entire vertical distance of the big rectangle is x plus 5. That's the whole thing. Do not use the 3's because those are horizontal distances. We use the 2's because those guys are vertical. So if the whole thing is x plus 5 and this piece is 2 and this piece is 2, how much is left over? So the game plan is to subtract these two values from the total. Okay, so what you have to see, it's x plus 5 minus 2 minus 2. So if you take the total and you subtract 2 and you subtract 2, what are we left with? Just the middle piece. And that ends up being the height of the little rectangle, which in this case is x plus 1. So the height over here is x plus 1 of the small rectangle. And we use the same argument to find the length. If we know the total distance is 3x plus 12, now we're using the horizontal distance. If the whole thing is 3x plus 12, and this piece is 3 and this piece is 3, how much is left in the middle? Well, you use the same argument, 3x plus 12, and you have to subtract out 3 from here, and you're left with the length of the base. So subtract 3, and what we're left with is 3x, 12 minus 3 is 9, minus 3 is 6, so plus 6. And now we have the dimensions of the small rectangle. So the area of the small rectangle is equal to length times width, which is equal to x plus 1 times 3x plus 6. Okay. So now we FOIL. X times 3x is 3x squared, x times 6 is 6x, 1 times 3x is 3x, and 1 times 6 is 6. Combine the middle terms, we get 3x squared plus 9x plus 6. And this is the answer for the small rectangle. Last step, what we have to do is find the area of the shaded. That means we have to subtract the big from the small. So keep track of what your answers are. So the small is this one, the area of the big was this, so we have to minus both answers. So area of the shaded equals area of the big minus area of the small. Area of the big was 3x squared plus 27x plus 60 minus 3x squared plus 9x plus 6. Okay. Since we have a minus, we think of it as a -1 and we distribute. So we get 3x squared. Let me erase this on the bottom. We get 3x squared plus 27x plus 60 and distribute the -1. So we get minus 3x squared minus 9x minus 6. Combine like terms and we get 3x squared minus 3x squared, they cancel, so you're left with 0. 27x minus 9x, you get 18x, and 60 minus 6 plus 54 units squared. This is the final answer. This is the area of the shaded region. This is a very typical problem, so make sure you're comfortable with these types of questions. We'll do more examples. Okay, so in this example here, it's very similar to the previous example we just saw, and it's asking us to find the area of the shaded region once more, but the information that's given is different now. So notice that now we're given the dimensions of the small rectangle, and we don't have the dimensions of the large one. We have to go ahead and find that. So we use the same argument. So keep in mind that to find the shaded region, area of the shaded, it's the same game plan. We take the area of the total, or the area of the big rectangle, and we have to subtract the area of the small rectangle. Okay. So let's go ahead and right away find the dimensions of the big one. So if we use the horizontal distance, notice that this piece here is x plus 3. How do we find the total? Well, if this piece is x plus 3, and this piece is 11, and this piece here is also 11, to find the entire distance, all you have to do is add all your horizontal distances together. So you're going to do x plus 3 plus 11 plus 11. So the total distance here is x plus 25. 11 plus 11 is 22, plus 3 is 25. Okay. Same argument for the vertical distances. So notice that the height of the small rectangle is 6, and over here we have 5 and 5. So you just add 5 plus 6 plus 5, and that gives us the total distance, which is 16. Okay. And now we're ready to go find the area of the big and the area of the small. So let's go find the area of the big first. We use length times width. The length is x plus, it doesn't matter which order you put these in, so let's do 16 here, times x plus 25. Whenever I have a binomial, I like to put them in brackets. And now here to find the area, we simply distribute. So we get 16x plus 16 times 25. It's what, 400? Yeah, 400. Now let's go get the area of the small rectangle. So the small rectangle, it's again length times width. So in this case here, we're going to take 6 times x plus 3. So I'm going to put the x plus 3 in brackets. And now we again distribute. So we get 6x plus 18. And now to find the area of the shaded, we subtract both our answers. So area of the big was 16x plus 400. Put it in brackets, minus the area of the small, 6x plus 18. Think of the negative as a, think of the minus as a -1 and distribute. So you get 16x plus 400 minus 6x minus 18. So 16x minus 6. Combine like terms, we get 10x. And 400 minus 18, we get 382 units squared. And this is our final answer. This is the area. Great work. Let's continue with another example. So once again, this example is very similar to what we've seen. We have to find the area of the shaded region. We have a big rectangle, and now we have a small rectangle once again. So same game plan. To find the area of the shaded region, you have to find the area of the big rectangle. And subtract the area of the small. So the dimensions of the big rectangle we have, so the top is 7x plus 2, the left side is 2x plus 7. The issue is the dimensions of the small rectangle. So we know the left side here is x. How much is the top or the bottom of the rectangle? So we have to use the same argument. Since we know the whole top is 7x plus 2, we could think of it as the whole total of the bottom is 7x plus 2. And since we know this section is 2x plus 3 and this section here is 2x plus 3, how much is missing? What do we have to do? So the game plan is to take the total 7x plus 2 and subtract these two distances over here, 2x plus 3 and 2x plus 3. Okay, so let's go ahead and do that. What we could do is add these two values first, get the total, and then subtract it from 7x plus 2. So let's do that together on the side. 2x plus 3 plus 2x plus 3, we get 4x plus 6, and now we subtract them. So notice that I'm subtracting the total, 7x plus 2, put it in brackets, minus 4x plus 6. Distribute the negative 1, and we get 7x plus 2 minus 4x minus 6. Combine like terms, 7x minus 4x is 3x, and 2 minus 6 is minus 4. So the piece here that's missing is 3x minus 4. And now we have the dimensions of the small rectangle as well, so we could go ahead and solve. So let's do that. Let me erase my work over here, just to give myself a bit of room. So let's go find the area of the small rectangle. So let's put our formula, length times width. The length, let's call it x, times the width, which is 3x minus 4. And we distribute. X times 3x is 3x squared, and x times negative 4 is minus 4x. And this is the area. Let's go find the area of the big rectangle. So the dimensions are 2x plus 7 and 7x plus 2. So always start off by writing down your formula and then plug in what you know. So 7x plus 2 times 2x plus 7. And again, if you reverse the order of this, it doesn't matter, you'll get the same answer as me. So let's FOIL. 7x times 2x is 14x squared. 7x times 7 is plus 49x. 2 times 2x is plus 4x. And 2 times 7 is plus 14. Combine like terms as usual. And we get 14x squared plus 53x plus 14. So we got our two answers. We found the area of the small and the area of the big. And now to find the area of the shaded, the blue region, we just subtract our two answers. So 14x squared plus 53x plus 14. All this in brackets minus area of the small. 3x squared minus 4x. And again, we think of this as a negative 1 and distribute. This is why it's important to put the brackets, not to forget this step. Plus 53x plus 14 minus 3x squared plus 4x. Okay. And now we combine like terms. 14x squared minus 3x squared, we get 11x squared. 53x plus 4x, we get 57x. And then plus the 14 that's alone here. And this is our final answer. The area of the shaded region is 11x squared plus 57x plus 14 units squared. Okay, the next problem is a very typical exam type problem. They ask us to find the pattern to obtain the fifth expression, or to find the missing expression. So our goal is to find an expression. So based off the problem we just saw, the first expression, expression 1, we have x squared plus 4 times x squared minus 4. So we have a binomial times a binomial. So this, what we have to do is use the FOIL method. So x squared times x squared is x to the 4. X squared times negative 4 is minus 4x squared. 4 times x squared is positive 4x squared. And 4 times negative 4 is minus 16. Okay, combine like terms, the two middle terms, we get x to the 4, and we get negative 16. So this is the answer for the first expression. What I like to do is I like to write them one on top of the other. So let's go ahead and do that, and I'll write it on the top of the board. So expression 1, we have x to the 4 minus 16. Okay, so this one's done. Let's erase. And let's look at expression 2. So expression 2 that was given is going to take up a bit of room. It's 2 x to the 5 plus 14x cubed minus 7x minus 10. All that in bracket minus 7 4x cubed minus 2x minus 1. Okay, so it looks very intimidating, but just break it down, do it step by step. The first thing you have here is a monomial times a polynomial. So in order to solve this, we distribute the 2 to everyone. Don't leave anyone out. So 2 times x to the 5 is 2x to the 5. 2 times 14x cubed is 28x cubed. 2 times negative 7x is minus 14x. And 2 times negative 10 is minus 20. So be very careful here. You don't want to make a mistake, because if you make one small little mistake, you lose the pattern. So you won't be able to solve the problem. So take your time, double check your work over here. The next step over here is to distribute the negative 7. Don't forget to include the negative. So negative 7 times 4x cubed is minus 28x cubed. Minus 7 times minus 2x is positive 14x. And minus 7 times negative 1 is positive 7. So the next step that we do is combine like terms. This is the only x to the 5, so we'll leave it, 2x to the 5. We have positive 28x cubed, and we have minus 28x cubed, so they cancel each other. So those are done. Next we have, there's no x squareds. Next we have negative 14x, and we have positive 14x, so those guys cancel as well. And lastly, we have minus 20 and plus 7. So negative 20 plus 7 gives us minus 13. And that's our final answer for expression 2. So let's erase our work. Make sure you got the same thing as me, 2x to the 5 minus 13. And let's write it on the top of the board. So expression 2, we get 2x to the 5 minus 13. Let's look at expression 3. Expression 3 is 2x cubed minus 1, all that squared, plus 2, 2x cubed minus 5, and then minus 1. So what we have to do over here is first deal with the exponent 2. 2x cubed minus 1 squared. Remember, don't distribute the 2. This is a very common mistake. This means to write this twice. So this is a secret FOIL question. So instead of writing squared, let's write it as 2x cubed minus 1 times 2x cubed minus 1. Okay, so that's clear now. We have to FOIL this one. Here we could right away go ahead and distribute, because we have a monomial times a binomial. So 2 times 2x is 4x cubed. And 2 times negative 5 is minus 10. And then we have minus 1. Notice the bracket stops here, so you do not multiply the 2 with the -1 on the outside. You have to leave the -1 as is. And next what we have to do is our distribution. So let's go ahead and FOIL. So 2x cubed times 2x cubed, you get 4x6. 2x cubed times -1 is -2x cubed. -1 times 2x is -2x cubed. And then -1 times -1 is +1. And then let's recopy the rest. 4x cubed minus 10 minus 1. Okay, and now we combine like terms. So we have the 4x to the 6th here. That's done. There's no other x6. Now we have x cubed. So we have -2x cubed minus 2x cubed plus 4x cubed. So -2 minus 2 is -4 plus 4 is 0. So those are gone. They cancel. Then we have the numbers 1 minus 10 minus 1. So 1 minus 10 is -9 minus 10 minus it's -10. And that's our final answer. This is the answer for expression 3. So let's erase our work. You could always pause the video if I erase it too quickly. And let's write down expression 3, and we can kind of see a pattern emerging. Expression 3. We got 4x to the 6 minus 10. Okay. So right now, try to find a pattern here and try to anticipate what you expect the next one to be. Okay. So you should have an idea of what expression 4 should be, but let's go ahead and still solve it. So expression 4, what we have is 56 x to the 8 y to the 8 minus 49 x y to the 8, all that divided by 7 x y to the 8. Okay, so we're dividing monomials, so remember we have to divide each term individually. So think of it as 56 x8 y8 divided by 7 x y8 minus 49 x y8 divided by 7 x y8. Okay, so 56 divided by 7, we get 8. X to the 8 divided by x, so you subtract the exponents, there's a 1 here, 8 minus 1 is 7, so it's x to the 7, and y to the 8 minus y to the 8, they cancel each other out. So we're left with 8x to the 7 minus, and then 49 divided by 7 is 7, x divided by x cancels, and y to the 8 divided by y to the 8 cancels. So we're left with just this, 8x to the 7 minus 7. So let's write this down. So expression 4 is 8x to the 7 minus 7. Okay, so our job is to find expression 5. So we solved everything. We have to find the pattern to find expression 5. And this is not easy, it's difficult, especially if you haven't seen these types of questions. But the first thing I do is I look at the coefficients in front of the x's. The first one here, it's not written, but we know there's a 1. The next one's 2. The next is 4, the next is 8. What's happening to the coefficients? If you're going from 1 to 2, you can say you're adding 1, then you're adding 2, adding 3. No, that doesn't work. 1 to 2, you're multiplying by 2. 2 to 4, you're multiplying by 2. 4 times 8, you're multiplying by 2. So you see the pattern here is it's not going up by 2, it's being multiplied by 2. Okay, so 8 times 2, the next one we expect is to be 16. Okay, so we have to find the pattern. Then we have x's. The exponent is 4, 5, 6, 7. So the next one is going to be, it's going up by 1, is 8. All the signs here are always negative, so there's a minus sign. And then we have 16, 13, 10, 7. What's happening to this number? You can think of it as it's going down by 3. So 16 to 13 subtract 3. To -10 subtract 3. If you're thinking in terms of negative numbers, you're actually adding 3. But if you're ignoring the negative because you already put it down and you look at just 16, 13, 10, 7, it's actually going down by 3 of those numbers. So the next one would be -4. And this would be the final answer. These are very difficult. It should take you about 10 to 15 minutes to solve this on an exam. But yeah, this is find the pattern question. Great job, and I'll see you in the next video.